All right, folks, these are the video answers to solving position functions for time using quad solver number 2, plus confirming the fire drill formula. So there's paper solutions links. Okay, and then I'll let you read the problem yourself. Write a position function for the cart. So x equals x naught plus v naught t plus at squared over 2. That's your general formula. This is the order that you want to make decisions. So the cart, you have to decide what is positive and what is negative. I'm going to call, this says x, this is x equals 0, and so up the ramp is positive. So it started 5 meters away or ahead, 5 meters away from the bottom of the ramp, so that's positive 5. It is heading towards the positive sign, so that's a positive velocity. T is the input of the function, so we want to leave it as a variable. And its weight, just like the demo we did in class, the weight is pulling it down, so it is a negative 2 t squared over 2. All right, sorry, I'm being inconsistent with units or no units. All right, we want to reduce that 2 over 2, so this is 5 minus 10t minus t squared. People don't like this as an answer because they think they haven't solved for something, but the problem didn't ask you to solve for something. It said write a function, which means we have an input and an output. So that is the answer. Now we're going to write the velocity function for the cart, which again has an input and an output. So the velocity function is my initial speed plus my acceleration times time. It's linear, just like the video lab. Okay, this is my output, so I'm going to leave it as the function. The initial velocity is 10, and the acceleration was minus 2t. So that is my velocity function. Okay, we're not solving for things, we're getting ready to solve for things. All right, use the velocity function to find the time that the cart comes to rest. So we want the output of the function to be 0. So the final answer is 0 equals 10 minus 2t. We're going to solve that for t. So let's subtract 10 from both sides. And then let's divide both sides by minus 2. So t equals minus 10 over minus 2, which is great because we know it happened in a positive time. So it took 5 seconds for the cart to come to rest. Then easy, 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 plug and chug. Take that time into the position function to find the max height of the cart. So x equals 5 plus 10t minus t squared. So x evaluated at 5 is 5 plus 10 times 5 minus quantity 5 squared. So it is 5 plus 50 minus 25 equals 30 meters. That's huge. So clearly I made up a bad question. 30 meters is huge. Okay. Now we're going to find the average velocity. So the average velocity is the initial plus the final over 2 because it's changing at a uniform rate. We did not start V naught. V naught was not 0, right? So don't go on autopilot. X naught wasn't 0. V naught wasn't 0. Initial speed was 10. It was headed up the incline at 10. We want the average to the peak just because that's what it asked for. So 10 plus 0 over 2 is 5 meters per second. Okay, and then we're going to check our work by using the alternative way to find location. Again, it's not really a function because this time is not any time, it's the time over which you calculated the average velocity. So it had a 5-meter head start, and on average, it was going 5 meters per second. And it did that for 5 seconds. So we have 5 meters plus 5 meters per second times second. So 5 meters plus 25 meters equals 30 meters. Yay. Okay, so sometimes on a test, I'm not going to tell you what equation to use, but sometimes on a test I'll say, all right, at the end of the test, pick any one problem and any one, subset of a problem and get this answer using a different formula, right? So this is one way to do it, using the position function or the don't know, don't care about acceleration. Okay, now we're going to practice using quad. Use the quad function on your calculator to find the 2 times the cart is at x at 14. So the output of the position function is 14, and I'm just copying the position function. You can't see it anymore on my screen, but you should have it on your paper. So that's what we want to be true. Oops, I dropped a T. Okay, we need to get this in the correct format. So I'm going to subtract 14 from both sides. Actually, okay, sorry. I decided to bring this minus t squared over. So that becomes positive t squared. Subtract 10t from both sides. Subtract 5 from both sides. Plus the 14 that's already over there. Okay, so I just brought everything over here so that I could say that it equals to 0. So we have 1 t squared minus 10t plus 9 equals 0. All right, and then in your quad solver program, this is A, that is B, and 9, positive 9 is C. Okay, A, B, C, plug that in, record both times. You get 1 second and 9 seconds. So it was at 14 meters, which is, again, stupid, crazy long. Past 14 on the way up, came to rest at 30, and then past 14 on the way back down. So that's what these 2 positive times mean. Okay, and then let's check your work. Average these 2 times. So average of the 2 times is T1 plus T2 over 2, which is 1 second plus 9 seconds over 2, which is 10. 5 seconds, which is what we got way up here. Find the time it comes to rest. 5 seconds. So the vertex of the parabola occurs at the average of any 2 solutions to the quadratic. All right, that was question 1. Then I'll let you read about Gabi. Use the fire drill formula to find her average velocity in this time interval. See, this is a time interval. So she went from 6 to 33 at a uniform rate. So her average velocity is 6 meters per second plus 33 meters per second over 2. So on average, she gained as much ground as if she would just went a constant 19.5 instead of speeding up from 6 to 33. All right, now we're going to use don't know, don't care about acceleration formula to figure out where she is, how far she has gone. Let's change colors just because. She does not have a head start in distance. On average, in that time interval, she was going 19.5, and the time interval is 4.8 seconds long. So she went 93.6 meters. Okay, and then fundamental definition of acceleration is what we did already. This is just the slope of the secant, right? Delta V over delta T. And we have two speeds and we have two times. You could do that if you wanted to, or you could use the velocity function and solve for A. On the written answers, I did this. So just to give you variety, you can see that we can solve this for A. Be careful though, we're not finding the time she come to rest. So where the output of the function is not 0, the output of the function is 33. Okay, she started at 6. At some later point in time, the output of the function is 33. And, oh, we're looking for A. I'm like, what's her A? Because we don't know. And that time interval is 4.8. All right, so then we're going to subtract 6 from both sides. And we get 27 equals 4.8 times A. And then we're going to divide both sides by 4.8. And A is going to be, so that's about 30 divided by about 5. So it's about 6. I'm just making sure that my numbers make sense because I'm just looking at my key and not calculating it to save time. I mean, I did on my key, but anyway, never mind. I'm not saving time if I tell you what I'm not doing. Okay. If you divide that by that, you get 5.625. It's positive because she is speeding up going forward. Okay, so now that we have the acceleration, you can use the position function to find out where she is because now we have everything in the position function. So x equals x naught plus v naught t plus at squared over 2. She did not have a head start in location. She started out going 6 meters per second for 4.8 seconds. She was speeding up at a rate of 5.625. Don't forget to divide by 2. And that 4.8 is squared. Okay, when you evaluate that in your calculator, you get 93.6 meters. Check. That is what we got using don't know, don't care about acceleration. Okay, so hopefully you're not feeling this is tedious. I just want you to have done all of the formulas enough times that you're comfortable using any of them. Okay, now we're going to find the 2 times that the car is at x equals 50. So we want the output of the function to be 50 equals 0 plus 6t because we're solving for t, plus whatever 5.625 is divided by 2, let's see, plus 2.8125 t squared. And then we're going to get it in the right format so that we can put it in our quad solver. So our t squared term is first, plus 6t minus 50. So I'm bringing everything over to this side. I just am writing this side over here. So that we can see this is A, this is B, this is C, and put that into your quad solver and you get t equals 3.28 and a negative 5.42 seconds. All right, don't freak out that you got a negative. The next question is going to explain why we only got one positive time. So clearly the positive time is what we're going to use if we want to do further calculations, but you've got to record both or I will take off points. Okay, so explain why there's only one positive time. If you look at what Gabi's doing, her initial speed is 6 and she's speeding up. So she's just going to keep going. I mean, not very realistic, but her vertex of the parabola is over here. She starts with some positive speed, and she's just speeding up faster and faster and faster. So she's only going to be at what distance did I say? 15, 50. She's only going to be at 50 at one positive time. The other time you can't see it on the parabola, and you can look at. I didn't want to waste time by. Oops, the vertex isn't there. She da, 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 what am I saying? Okay, so she's at 50 one positive time and one negative time. So the picture of the parabola shows you, and remember, she's a concave parabola because her acceleration is positive. But from a physics, like real world point of view, she starts with a speed of 6, and she's just speeding up. So she's just going to head away from where she started faster and faster and faster. She's just never going to turn around. So she's only there once. Oh, and then the challenge question is explain why the second time is negative. So in my answer key, I can see that I must have Desmos graphed this more carefully, and she does not have a head start in position, which it looks like she does there. But the vertex of the parabola is somewhere over here. And I already said this, but she is at 50 at one positive time and one negative time. All right. So again, practice with lots and lots of equations. I think this worksheet kind of told you when to use which one. And your job is to get comfortable enough with them that you are flexible and, can figure out what you need to do, but we're still practicing. All right. Thanks for listening, and I'll see you in class.